In this video, I'm going to talk about Bezier curves. Now, Bezier curves are a type of linear interpolation between multiple points. And so the first one that we'll talk about is just a linear Bezier curve, which is just two positions. We'll say this is P1 and this is P2. Now, a linear interpolation between these points can be calculated as the position is equal to the initial position, P1, plus the time times the delta between the two, P2 minus P1. This essentially calculates the distance between P2 and P1, multiplies by our time, which is a value as time goes from 0 through 1, and then, which is essentially like a percentage of how far along it is from P2 to P1, and then adds that distance back to the original position. That gives us the final position at P sub time. So what this ends up looking like, we have position 1, position 2. If we want to calculate when time is equal to 0.5, so we are halfway between P1 and P2, it's going to be this position right here. If we want to calculate when t is equal to 0.75, we're 75% of the way there. It's going to be this position right here. And when we want to look at t is equal to 0.25, so we're 25% of the way there, it's going to be this position here, right? Now, these are all along this straight line. Now, for a Bezier curve, or for a linear interpolation like this, what you'd be doing is you would be increasing t from 0 to 1. So you can see when t is 0, it's going to be down here at this position. And then as it goes to 1, it's going to move along this straight path, right? Now, the really cool thing happens once you start going to quadratic Bezier curves and you start using a third point. So let's imagine that there is a third position on this already set of two positions here. We'll call this P3. We're turning this into a quadratic Bezier curve. A quadratic Bezier curve uses essentially this method of doing a linear Bezier curve, except it does it twice. It does once between P1 and P2, and then again between P2 and P3. And then finally between the resulting points of those two. So for t is equal to 0.5, we would calculate the halfway point between P1 and P2. Then we would calculate the halfway point between P2 and P3. It'd be a position somewhere around here between P2 and P3. And we're doing this the exact same way here, where we're picking the resulting point, this value here, and we're saying the start point, which would be P2 in this case, plus the time, which is 0.5, times the delta between these two positions. This will give us this resulting mid position. Then finally what we do is we look at these two positions. So we've gone from 3 points down to 2 points by using this linear interpolation. And now that we're down to 2 points, we're going to do the exact same thing again, using these 2 points as P1 and P2 in this formula here. And we're going to get a resulting position of about here, which is halfway between these two positions. Now let's look at t is equal to 0.75. At 0.75, between P1 and P2, we're about here. Between P2 and P3, we're about right here. And then we look at these two positions. At 0.75, we're about right here, right? 75% of the way between those two positions. If we look at t is equal to 0.25, 25% of the way there. Between P1 and P2, we're here at this position. Between P2 and P3, we're here at this position, approximately. And then between these two positions, we go 25% of the way. Now, the really cool thing about this is as t smoothly goes from position, like from a value of 0 to a value of 1, this creates a curved line, which is where this Bezier curve comes in. So this is a form of doing interpolation that creates a nice smooth curve using these three control points, P1, P2, and P3. This is really similar and is used in a whole bunch of different graphic design software. When you go grab that pen tool in a lot of the Adobe suite of tools, this is most likely what it's doing. Or if you look at something like the roads in the game City Skylines, right? Most likely it's doing something along these lines, where you are building roads and creating these curves based on Bezier curves. So we started with the 2 positions, which is a linear Bezier curve. We went to 3 positions, which is a quadratic Bezier curve. Now we can go to 4 positions, which is a cubic Bezier curve. Let's do that real quick. Here's P1, here's P2, P3, and then finally P4. And these positions work no matter where they are in your space, right? Now, again, we're going to use this linear interpolation function, and we're going to use it to reduce 4 points to 3 points to 2 points, and then finally go down to 1 point. So the process here, t is equal to 0.5. That's my blue marker. Between P1 and P2, it's about halfway there. Between P2 and P3, it's about halfway between them. Between P3 and P4, it's about halfway between them. Right, here are our 3 positions. Now we've turned this cubic Bezier curve problem into a quadratic Bezier curve problem, right? We've reduced it to 3 points, just like we have up here. So we can find the midpoint at 0.5, t is equal to 0.5, between the first 2 points, which is somewhere around here. And then we can find the midpoint between these 2 points, which is somewhere around here. Now we've reduced it down to a linear Bezier curve problem where there's just 2 points, and then we find the midpoint between them, and there is our final position. So based on these 4 control points, we calculated one final position, which is right here at this dot, approximately. Let's do the same thing with t is equal to 0.75. 0.75 between 1 and 2 is roughly here, 2 and 3 roughly here, 3 and 4 roughly here. Between these two, it's roughly right here. Between these two, it's roughly right here, and then 0.75 between these two ends up being somewhere around right here, right? So there's our final position in red. Now with 0.25, same thing. P1 to P2, there's about 25%, P2, P3, 25%, P3, P4, there's our 25%. Now we have these 3 positions. Between these two, there's our 25%. Between these two, there's a 25%. And then finally, between these 2 final points, here's about our 25%. And so the neat thing that you can see here is you can kind of see this curve that's starting to take shape, right? So we started with these initial lines, which looked something like this, right? And then our final curve between all of these is going to be going through, what did I end up here? This position here, this position here, this position here. We are going to end up with something that looks akin to this, right? Which has this, like, this sloping. So we're creating this Bezier curve, this cubic Bezier curve, using 4 control points, using this one linear equation. This one linear interpolation function is what it all boils down to.